Everyone. Today we will discuss units. We will start a YouTube channel to explain or to study for the FE Fundamental of Engineering exam, and we will be focusing on chemical engineering. We will use the FE Review Manual book and the FE Practice Manual book too, so we will use two books. And the first chapter in the review manual was about units. So we will talk about units. So what is units? Units actually is a tool of measurement, okay? So we have something that we know, like for example, we have foot. So as humans, we know or we can visualize the size of our foot, okay? And we want to compare to unknown distance. So we know the distance between our foot, like it will start here and end up here. This is a foot. This is noun, this is fact, and we want to know or to compare it to the distance to this wall, for example. So it's kind of a philosophical idea. So we will say, my foot is this size, and this distance, sorry. So the distance in the start of my foot to the end of my foot, compared to this distance, will be like 1, 2, 3, 4, 5, 6 feet. Or 6 feet. So we have an idea now how far this wall is from us. Okay, so it's pretty philosophical meaning, but yeah, so it is just a tool of measurement. It is tool of measurement. So we have guys. So as we know, we discuss foot. So here we will discuss about mass. Those two are the most important tool of measurements that human use. Okay, so where's the difference between mass and weight? Well, it's pretty easy, because mass doesn't depend on force or on on acceleration or gravity, etc. So my mass in Earth is the same at Moon, so it's constant. But if we talk about weight, so mass is just constant, but weight is equal to this mass times g, which is the acceleration of the gravity. Okay, and here, guys, we have the most important tool of measurement. We have length, we have mass, time, current, temperature, etc., frequency, force, pressure, energy, power, pressure. I mentioned pressure, I guess. So as a non-engineer or as an engineer, we deal with those stuff in daily basis. We deal with seconds, ampere, meters, kilograms, pounds, tons, etc. Here, foot, inch, Celsius, Kelvin, Fahrenheit. So we, as engineer, we should know where is the tool of measurement. We should be familiar with Celsius. We should be familiar with Fahrenheit. We should be familiar with meters, foot, inch, kilogram, pounds, etc. And that's why we have more than one system. So we have the SI system, what is, I believe it is originally a French system, which become an international system. And we have the British or American system, British American system. So they are not the same, like, and even when we apply the law of physics, they are not the same. Okay, for example, let me give you an example. We have F, which is force, is equal to what? It's equal to mass times acceleration. Okay, so in SI, let's say M is equal to 6 and A is equal to 2. Okay, this is kilogram, sorry, this is kilogram, and this is meter per second square. Okay, so when we apply, or we want to know what is the force, so the force is gonna be 12. Okay, 12 kilogram meters per second. This value, focus guys, this is important, this value is Newton. Okay, this value is Newton. But in the British system, and here is the confusion, in the British system, what we will do, let's say for example, M is equal to 6, bound mass, and A is equal, acceleration is equal to 2 foot per second square. And the force is gonna be what? 12 bound M foot second square. Focus with me, guys. This guy, like the force, or the force unit for in British system is bound force. Okay, it is bound force. Okay, so that value, or that those units, does not equal bound force, not like the SI units. So what we will do, we will have to bring a convergent factor. So we will bring something called the GC, which is 32.2. So, and the unit of that is bound M foot times, or divided by second square bound force. Okay, so we will take that value, 12 bound M foot second square, and divided by this value, 32.2 bound M foot second square bound force. We will see that will go with that, that will go with that, that will go with that. The bound force will go up. So yes, the British system is a bit complicated, So let's take an example. Here we have, this is the mass, 4K, and we have, this is the speed, and he wants the kinetic energy. So as we know, kinetic energy is equal to mv squared divided by 2. But notice, guys, he wants it in foot times bound force, foot times bound force, foot times bound force. So we will put the GC. Okay, we will put the GC because we want it in bound force. So we will say we will say M is 4K and V is 27K squared divided by 2 times 32.2. Okay, we'll get B. If you want, I can do units analysis for this, so it will be clear for you. Okay, let's do it. So it's 4K. The unit of that is bound M, and we have here 27K squared. So the unit of that will be foot squared, second squared, and 2 is dimensionless, and 32.2 is going to be BM, okay, BM foot divided by second square times bound force. So that will go with one of those, and that will go with that, and that will go with that. So we will end up with 4.5 times 10 to the power 10, and it will be foot bound force. Okay, so another example here, we have the mass 10 kilograms, and the vertical distance is 3 meters. Where's the most? He wants the potential energy. Okay, so he wants the PE. Okay, potential energy. It is mg delta H. So basically we will say he wants it in joules. So focus with me, guys. So 3 times 10, so we have 10 kilograms time G is 9.1, and this is meter per second square times 3 meters. Okay, so we will get, let me calculate this, guys. Let me calculate this. I think it is 294 kilogram meter per second square times meters. Why I put it like this? Because this is Newton, as we learned before. Like if you go up, where's in Newton? This is Newton. Okay, this is a Newton times meters. Newton times meters is joule. Okay, so it is joules. So the nearest value is this. Okay, sorry. So here is, we have the practice question examples. You can try to solve it by yourself, like read it, try to solve it. Like stop the video a little bit and try to solve it by yourself. Okay. What basic SI unit is equal to this value? We just solve it, guys. We just solve it. We said here what? We said kilogram M divided by second square times M is joules, right? It's joules. But the difference is he put this, he just changed the form. So it is joules. What is kib? Kib is kilobound force. So it is 1000 kilobound force. What is ton? Ton, like, guys, 1000 gram is equal 1 kilogram, right? And 1000 kilogram is equal to 1 ton. So it is B. And I hope that was helpful. Thank you guys for listening, and see you in the next video.